So now our next speaker is Sergei Belan, and we will be talking about results of photopolarimetric observations of UX Ori at a uniquely deep minimum.
Hello. My name is Sergei Belan, and I want to present you some results of photopolarimetric observations of UX Ori at a uniquely deep minimum. We will carry out at Kremlin Astrophysical Observatory with the help of 1.25 meter telescope and Belan's photometer polarimeter. Go next. Он работает. That's with variation of the parameters magnitude, polarization angle, position angle, polarization degree as a function of time, all in V band. At the first graph, the black dots, that's crowd data. The whole black dots, that's SN data. Small dots, not whole. The red dots, that's crowd data at the first season of observation of uniquely minimum. And the blue dots, that's crowd data is the second of observation, that's minimum. Also, here we see the UX Ori light curve we are building with the help of LSO data. The time scale on this graph is about 10,000 days, but our data have only 7 years. About next one, the long minimum of UX Ori observed in 2018-2019 had some characteristics typical for the prototypics of like UX Ori. The first one, it's regular variation consisting of day scale deep minima overlapping with year scale variations of average brightness, as we see on this figure. And the second is usual bluing effect, usual pattern of colorations with initial reading and then bluing below same brightness level. Here is, and some degree of polarization brightness correlation, of course. But some characteristics that are less usual and are not easily explained by a simple variable absorption plus constant disk scattering model. The first is at a very high degree of polarization, more than 10% in where even in red bands RNI, where even in the deepest minima, color indexes indicate that non-scattered light still dominates in observed flux that we see on these graphs. We have almost not see the bluing effects. Then the second is this highly variable position angle of polarization. And polarization brightness correlation is far from perfect. When one compares data of several years observational seasons of even inside some season, show what node scatter of blue dots after 11.2 magnitude in wave band. Probable interpretation of this minimum. Position angle variation may be caused by the additional constant component, usually interstellar of polarization, to a variable component with a constant polarization angle, position, sorry. But in such cases, position angle is ambiguous, determined by polarization degree. This is not the case for our data, as may be seen on these figures. Examining Stokes parameters of our data, there is no predominant orientation of polarization vector for the whole data set. And even inside some seasons, exemplary red, the first season of our observation, red dots, thus the variations of position angle and angle with about 45 degrees range are heuristic and reflect changing geometry of polarization, including mechanism. If a mechanism is scattering, gradual changes of position angle during 3 years of minimum may be interpreted as a gradual changes of a scattering geometry due to the material motion of some large-scale structure, dust structure, which causes the long minimum that we see previously graph. But this interpretation does not explain wide variation of polarization parameters on shorter term scale, which also are weakly correlated with brightness variation, as we see on figure 4. The alternative may be interpretation is diachronic absorption by line dust grains with varying direction of line of sight. That's all. That's preliminary results. The work is in progress. We will work further. Thanks. Thanks for attention. Please don't ask the questions.
Okay. So, any questions?
You said that you observe very large changes of polarization orientation on short-term scales. Could you give a rough estimation which time scales and what is large change of polarization angle?
Time scale is, так, сейчас, секунду, degrees. Вот. Time scale is about for example, here the blue dots. It's about no, over 50 days. Yeah, maybe a little more.
Okay. Any further questions? One comment.
You absent in the first day of our workshop, and that day Sergei Schulman presented the model which explain the polarimetric variations when the position angle can change strongly. This is a new model, and it seems to me that it will be good for explanation of such changes.
Any other questions?
Yeah, but 10% of polarization.
He can say more.
It's too much for your mechanism.
For his mechanism, yeah.
Our model in development.
Like all the models.
Very nice.
Okay, is there any more questions for Sergei? If not, then Thank you again.